Hi, it's Robin. I've got one of my more unusual computers here today. It's the Commodore B128-80. It's part of the short-lived and fairly unsuccessful line of CBM2 computers that Commodore intended to replace the PET computers with around 1982. In Europe, these were known as the Model 6 and 700 computers. So I think this one may have been considered a 610 or 710 in Europe. Commodore was actually trying to develop many different computers to replace the aging PET line in the business market, and this is one of the few designs that did make it out to market. I think the initial retail price may have been as high as $1,700 for some of these models, but then Commodore quickly abandoned the line and focused on the Commodore 64, which of course was much more successful. This computer has double the RAM of the C64 at 128K, runs at 2 MHz compared to the Commodore 64's 1 MHz, has a 6509 processor which added an extra 4 addressing lines so that it can access up to 1 MB of RAM, has an 80 by 25 column monochrome video chip, essentially the same as in the 80 column PETs it was replacing, and strangely has a SID chip, the same famous sound chip that the Commodore 64 has. Thanks to my friend Golan, who was the previous owner of this computer. I got it from him in Toronto many years ago and flew it home. Airport security were very concerned about this. I remember them even swapping it in several places and running it back and forth through the security scanner. I think the keyboard's absolutely gorgeous on this computer. Down the left side we have extra keys that most earlier Commodore computers didn't have, like Escape and Tab. Early PETs didn't even have a control key. 10 function keys are included, and individual cursor keys, though unfortunately they're located up here. Classic clear home button is here, as is the reverse text on and off button. Another new one called norm graph, and the classic run/stop key. For my friends who insist run stop is a single word, run stop, I think they should apply the same to norm graph. The instant delete, INST, which is actually insert, and delete key has the T dropped, so maybe people will be a bit more likely to realize it's insert. The return key is very stylish, although you gotta wonder about squeezing the pi key in between it. Commodore key hidden right down here. It sure looks smart. Bit of an odd place for it. And this number pad is entirely brilliant. This absolutely means business with a clear entry button on it. And even a 00 key? How many computers have a 00 key? And things like the double quotation marks are moved down into this location like more modern US keyboards. And just to get an idea of the size of it, it's actually only a little bit wider than a bread bin C64. You can get an idea of how it's much, much deeper and a fair bit taller even than the big, bulky bread bin. It's got really nice curves. There were rumors for years that Porsche had designed this, but it was actually designed internally at Commodore. Unlike most Commodores, it has no ports at all on either side. The power supply is located inside the machine, so it just takes a standard power cable. There's the power switch. It has the IEEE port for connecting a disk drive. There's the cartridge port. I think is a different size than any other Commodore machine. And until recently, I don't know of any cartridges made for it. But actually, there was one game made about 5 years ago for this machine. Cassette port, video output, standard RS-232C, 25-pin serial, a reset button. Oh, and I almost missed it. There's the audio output for the SID if you don't plug a cable into that, it actually has an internal speaker that plays the SID output. And on the bottom, this is 2 large vents, and the badge, model B128-80, and serial number C009327. I've heard that there were maybe 10,000 of these machines made. I don't know if anyone knows for sure. One other interesting thing about this machine is that after Commodore abandoned it, the remaining stock was liquidated, and lots of people picked these machines up inexpensively, or relatively inexpensively. People who had bought the machine at full price were, of course, very unimpressed, and even those who were buying it at discount prices like $500 were unhappy that Commodore was abandoning it. So actually, a number of users in the Chicago area created a users group called the Chicago B128 Users Group, CBUG, in 1985, and actually formed a very large users group that ended up producing a fair bit of software and hardware for this machine. And very notably, they managed to petition Commodore for all the engineering resources, like all the documentation, all the inside information, hardware, and so on. Commodore handed all that over to CBUG for continued development, which really was quite remarkable. There'll be links in the video description to some excellent websites about this, so you can do some further reading if you're interested. Okay, I'll hook up this machine and we'll see some of the things it can do. All right, let's power it up here. And it takes a few seconds longer than most Commodore 8-bits to boot up. There we go. I think it's doing a RAM check during that time. So here we are in Commodore Basic. It says version 4, but it's actually version 4 plus. They've taken the Commodore 4 that's in the later Commodore PET computers and added quite a few new commands that I think actually found their way into the Commodore 128, not the B128, but the later Commodore 128 from 1985. So we should be able to do a little for loop here for x equals 0 to 15 for each of the memory banks, and then print the bank number and the amount of free memory in that bank. Okay, let's try running that. Okay, yeah, and bank 1 and 2 each have 64K, a little less than that right now, free. Bank 15 is reserved for the operating system, and I think Bank 0 is reserved for the processor, but I actually don't know what that means. So if you had a 256K model, Banks 3 and 4 would have another 64K each. And like some other Commodore 8-bits, the way the BASIC is extended to use the extra RAM means that you can have a full 64K for your basic code, and then another 64K for variables. If you have even more than that, then it will actually even split, I think, either arrays or strings into their own bank and numerical variables into another one. Something like that. Anyway, it's a simple way of giving you significantly more free RAM for your basic programs. This basic 4 Plus adds a proper if-else. We start off in this normal text mode where we've got both lowercase and uppercase. So instead we can use this graphics key to switch to the familiar uppercase and graphics mode. And then write a little program here. Go just if a random number is less than 0.5, then we'll print the slash that direction, semicolon, and you still have to type a colon, but then you can use the else command. Else we want to print, quote, and this is a little weird, Shift M gives us that slash that way, so you might think that Shift, the key beside it, would give it, but no, that gives a less than symbol. So even though they're both printed on the front, to get that one you use Shift. To get this one, we use the Control key. There. Pretty strange. And again with the semicolon. And there we go. Go to 10. Let's try that. There we go. And that chiming sound, every time the printing reaches near the end of a line, that bell sounds to tell you that you're near the end. You're going to exceed your line soon. Has a very different look to it with the 80 column. They've added an in-string function where in, say, the string hello, where does the substring low occur? And it gives the character position of 4. Okay, it's also got error trapping, where we just go, we're going to do trap line 100. Oh, I'm going to use those double zeros. Save the keystroke. And then we'll just deliberately do an error, like spell print as prompt, end the program, and then on line 100, this is our new error trapping routine. We're going to print out these special variables, the error line number, the error number, and the error string. And then use the resume next command, which is basically like returning from a subroutine, but just means that now that we've dealt with the error, well, all we're going to do is print the error, but you could handle the error and then resume. See if this works. So we're going to run. Oh, so I think I have to pass the error number in as a parameter to that ER string. Let's see if that works. Run. Yeah, there we go. Okay. I had an error in my error trapping routine. So that's potentially very powerful, where instead of errors causing BASIC just to end, you can instead deal with them and continue the program running. Much more robust BASIC as a result. Actually, that makes me wonder, for x equals 1 to 50, I actually don't know how many errors there are. So I'm going to print x, comma, error string, x. And this should print out all the errors. Ooh, it didn't like one of them. Okay, so it looks like 42 is the maximum number of errors. Not used to these cursor keys. 42. And one of those errors, at least, has some special control characters in it. Maybe error 19. We'll just print from 1 to 18. Okay, well, there must be a control code embedded in at least one of those errors. Okay, there's also commands like bload and bsave for saving a block of memory. Interestingly, it does not have special commands for the SID chip to make sound programming easier. You still have to do pokes. And there's several other features. I'm not going to show them all. But it's a nice BASIC, certainly for 1982. Okay, so if we put a little program in memory, okay, and we'll just go into the monitor. Okay, and this monitor is very much like the one built into the earlier Commodore PETs, but it has been extended to handle the extra addressing, the banks of RAM the B128 has. And we can look at memory. Now these first two locations, 0 and 1, just like the 6510 processor in the C64, locations 0 and 1 are special for memory mapping. On the 6509, these are an extra 4 bits that point the processor to the 64K bank that you currently want to use. So if we change this to bank 1, which is where the basic program is stored, we should be able to see, I'll just dump the first 256 bytes of memory, and we can see right here, 48, 49, why so many zeros? Oh, I corrupted it. Okay, obviously that's not the right way to do that. Oh. So we can set the bank. Normally you start off in bank 15 or OF. We'll go into bank 1. And now if we do a memory dump from 0 to, say, FF, we can see that basic program where it lies in memory. Here we go. This is line number 10, A in hex. That's the token for the rem remark, a space. And then here are the hex. I typed in the whole alphabet there. A is hex 41, 42, 43, and so on. There's the whole alphabet, all the way up to Z. And then 0 indicates the end of the line, and the 00 indicates the end of the program. We won't get super deep into this, but that's just an example of how the monitor allows you to look at all 128K or potentially more of RAM. Okay, and just to demonstrate a game. Okay, so this game, Space Chase, was released in 2016 made by Christian Krenner, and music by Max Hall. It's a rare example of a game for this computer, and while graphically it's just very much like an 80-column PET game that uses PETSCI, what's really cool is that it has a great SID soundtrack, because yes, this computer has a SID built right in. So, as it says on the screen, the CBM 2 game, that was 35 years late. If only they had made this back in 1981 or 82. So I'm not very good at this. It is potentially 2-player. I'll give it a try here. Press A to fire, D and F to rotate. Pressing 1 to start the game. Get ready. So I'm on the left side there. And it seems the only way to do well in this game is to use the auto fire, just to hold that fire button. Sorry about the continual sound effect for the shooting. It's a pretty confusing game. And it's got a strange aspect ratio because of the 80 by 25 column screen. There we go. Oh yeah, so the other thing that's neat about this is that this game actually saw a physical release. I don't have it, unfortunately, but they actually released it on cartridge. So as far as I know, that is the one and only cartridge available for this system. So congratulations to everybody who, managed to make that happen. That's a really cool achievement. How many times does that happen? That system has a cartridge port, but nobody makes a single game for it. And then they finally do make it 35 or whatever years later. I'm sure there are other games made for this from that users group, but if anybody has any suggestions about a really a killer game for the system, I'd like to hear about it. We'll take a quick look inside the system. Open up here, just remove the keyboard cable and power. And some of the major chips here. Here's the RAM in this area. And actually, I'm surprised to see this looks like I have the full 256K. But if I do, it's not showing up in BASIC anyway. Here is the 6551 UART, which handles the RS-232. There is the 6581 SID, unsocketed, unfortunately, with a date code of the 22nd week of 1983. And there's the main processor, the 6509, 51st week of 1982. And the input-output chips, the 6526 here and here, which are also shared with the Commodore 64. They handle things like disk access and reading the keyboard. And I believe those are the ROMs for the BASIC and operating system. And these headers are apparently for CPU expansions such as the 8088 and Z80 processor, I was going to say upgrades, but I think they're kind of like downgrades, but anyway, to allow CPM or MS-DOS to be run on this machine. And I believe those were eventually produced by that CBUG users group. Okay, that's a quick look at this system. There's probably a lot more to explore about it. Again, check out the links in the description for a lot more information. There's some excellent people like Steve Gray, Bo Zimmerman, David Vinner, who have excellent websites about this system. And it's a whole nother Commodore universe that's actually surprisingly rich if you want to get into that. Hey, thanks to my patrons for their support. Thank you for watching, and we'll talk to you next time. You don't shed, and you don't scratch. You don't ruin the furniture or howl at the door. You don't need food, and you don't make a mess. You're my favorite pet.